folks, it's Chris with Microsoft here again with another exciting episode. In this video we're going to be covering performance. We're actually going to start an entire new series and playlist covering strictly performance. Now, some of you may already notice there is a performance playlist. So that started with why is my DC slow, and in that video I promised everybody that I've been wanting to do this for some time. So I'm really excited about this. This is going to be a series that's going to teach you how to help when you have a computer that's just slow and we don't know why, and all the different processes that we go through to really identify that, are the processes we should be going through rather when we see that we have a slow system. So what we're going to be doing today is talk about the stuff we normally do, which is for instance going into Task Manager and trying to figure out what might be our problem, which is where most everybody starts. But performance for a really long time, even for seasoned professionals in IT, seems to be one of the more elusive problems. And there's a lot of tools out there, and not a lot of folks know how to use some of these tools. I mean, obviously everybody knows how to get in here to Task Manager and look at that. And a few of you may have fiddled around a little bit with Resource Monitor. And Resource Monitor is awesome. There's a lot of great tools in here. And maybe you've used some of the system internals tools and done some Process Explorer and Process Monitor type tools. And that's great. That's great. But not a lot of people use perfmon. And that's a big part of what we're going to be talking about in this series, because you can't always catch a problem live, for instance, and we can't always kind of pick up on trends, and we can't really pick up very easily inside of a 60-second capture window of performance inside of just standard perfmon by looking at some of the default counters that are showing up. So obviously, whenever you have a computer that is slow, you've been contacted either by an end user because you're an IT person, or you are dealing with hey, something bad happened last night and we need to figure out what it was, or maybe you're one of the people who are just simply a person who is classified as good at computers, and therefore all of your friends and family call you all the time. And there are certain things that you've probably done going into like details and sorting by CPU, but getting beyond that, into what I like to call the big boy IT tool sets, and really kind of dig in and try to figure out why it is that a computer is slow, breaks down to kind of a methodology, kind of a process. And there is no mistake at all that here in the Performance tab, when you go into Task Manager, you'll see these things broken out by network, disk, memory, and CPU. Because those are the four big bottleneckers that you run into when a computer is slow. If it's slow, it's typically because of one of these four things. Identifying which of these is kind of step one. Identifying what's causing it is step two. And that's the part where I think a lot of people get confused. And I think another reason people get confused is when they're looking at a tool like perfmon and they launch this thing up and they take a look at it. It's not like Task Manager necessarily, because a lot of times the stuff that you're looking at on the graph is difficult to read. First off, when you go in here, there's really not much showing up, right? You've got this one counter and it's going, and this counter happens to be a good fit for the graph that it's in. But let's say you were trying to do some some analysis on disk activity. Let's just go to physical disk and just talk that. So a lot of people get really confused because they're not sure which of these counters they need to use. They're not really sure which ones are important. And even if you knew, for instance, that maybe read and write times were kind of important, you top those into the graph and look at them, and where are they on the graph? Well, they're way down here at the bottom, right? They're way down here at the bottom. So maybe a few of you found the highlighter tool and could go in here and actually see where they are, but is that bad? Does that mean good? Is this graph representative of what the top would be bad? Or would somewhere here in the middle maybe be where we would expect to call it a problem? Because when we start looking at these, graphs, our eyes tend to think of the top as bad and the bottom as good, unless it's an inverse counter like available megabytes. In that case, the top is good and getting close to the bottom is bad. But the problem with perfmon is the counters have really no relation whatsoever to do with the graph, except the percentage counters. That's fairly helpful. But the average disk per second write times, what does that actually mean when we look in here? So that's the point of this series, right? We're going to cover some of the key indicator counters that you need to be looking at, and when to use perfmon versus task manager or resource monitor for troubleshooting. And that's kind of the point of this whole thing. So when you're dealing with an issue that's happening right now, resource monitor, task manager, they can be pretty good tools, right? I mean, they're handy. They're right there. You can control, delete, and go to task manager, and right click off of the taskbar and get to task manager. A few of you have probably been working with the Windows 8 / Windows Server 2012 version of this enough to know when you come over here to the performance tab, you can probably right click and go in there and change from one view of an average to an overall utilization. If you work with servers much, you may have noticed that the disk counters are not even available on the server. That's actually easy to fix. You just type in disk perf. And for those of you who are watching this in standard definition, you might want to kind of increase this to a higher definition. I'll get Zoomit installed on here when we really get into anything command prompt related. But this one's easy. This is just diskperf-y. And if you do that, the next time you load up Task Manager, it'll actually have disk counters in here. By default, Windows 8 already has that in there, but if you like looking at the disk counters on a server as well, you can get those. It's an easy little command. So that command again was diskperf and space and then -y. That adds the logical and physical disk counters in. So anyway, it's going to be fairly easy looking at a graph like this when a problem is going on right now. And then of course, obviously you would, if you knew, okay, this computer's slow because we're running out of memory, you can go over to the details tab and sort by memory. And this is kind of elementary school stuff, right? We all know how to get that far. CPU, we sort by CPU, figure out who it is. In this case, it's active identity. We could do something like in the task on it and kill it, right? So now that that's been done, we should see that processors are a little bit less bound. Simple as that, right? But it's not always as simple as that for a lot of problems that we deal with. So we look at things like Resource Monitor to get a little deeper, because with Resource Monitor, obviously you've got your 4 tabs for the 4 commodities we were talking about before, with your processor and your memory, disk, network, and in this case we would have been looking at CPU. If we wanted to see what some of the sub pieces of some of these were, like SVC host or system, a lot of times those are a little difficult to tell what what is going on just by looking at something called SVC host and task manager. The neat thing about Resource Monitor is it tells you right here what it is. Okay, so if this SVC host with that PID that you saw was at 100% CPU utilization was causing you problems. Here, at least you get kind of the description of which services that service host is hosting, right? So that would have been my, a network one, and that's net services and net service, IAC service, DCOM launcher, and if it was the DCOM launcher that was a problem, I could click the checkbox on that. That means just show me this, and I can come down here and look at services that are owned by this particular instance of SVC host. We can come down here and look what handles it's got open, and we can come down here and look at, let's see, I think that, yeah, okay. My scroll's not working very good. Associated modules. Now we come down here and look at the modules that are going on. What's really handy with this as well is because if, let's say, we had this service host, now we can look and see which services it is that is actually part of this particular bucket of resources. And you can see which one of them is kicking the CPU up really, really high, and then you can dig in from there. So Resource Monitor can give you extra views into stuff that you can't see in Task Manager. Like if you're running out of RAM, for instance, this will tell you the commit limit, working set, the shareable memory, and private bytes of each of these processes that you're looking at in your system. So that's good for real-time type of troubleshooting and being able to tell what you've got going on right now. Same thing with disk. Obviously, we can see disk activity. It looks like this particular SVC host is, showing local service, and I didn't pull it out far enough. There we go. So local service with no network, disk activity. We can see that we're doing write bytes a second at 956. That's how many writes bytes of write operations and stuff is going on. He's doing no read operations right now. I don't know what drive he's doing and what queue we have on that particular disk right at the moment. So that can help you figure out, once again, live what's going on. But to really get in a little deeper, you need to understand how to troubleshoot problems that aren't necessarily going on the box right now. Because a lot of times the descriptions you're going to get is, hey, it happens all the time. Well, how often does it happen? It seems like it happens a bunch of times a day. Okay, well, you're not getting terribly descriptive information from your user, which isn't terribly uncommon, right? So what you need to do is you need to figure out how you're going to find that data. Are you going to sit there and stare at the screen until the problem happens again? Probably not. You've got better things to do with your time. So at this point, what you really need to do is you need to gather information. You need to capture data over a period of time, and that's what perfmon is for. And that's going to be the point of the counters that we're going to load, so you understand how these counters that I'm going to show you will lead you to initial indicators to tell you which of these four guys is what's causing your problem. Understand what the counters actually mean, what they measure, why they're important, and then we're going to show you how those initial indicators will lead you to then using secondary and tertiary counters to determine not only what it is that's slow about this particular computer, but also what it is that you can do to determine which maybe process or service it is that's got you bottlenecked. So that's going to be kind of the point of this series. So that's what we need perfmon for, because this graph isn't what perfmon's all about. This is kind of a neat little graph and all. I mean, you can throw your counters in and make your own little version of Task Manager, but perfmon, where perfmon excels is for troubleshooting periods over time. You've got an issue that pops up every few hours and the computer just flakes out. This thing is loaded and running locally on the box at all times after you have told it to, gathering data for you so that when the box gets so bottlenecked and bogged down, maybe you can't even remote desktop into it, or if it's a family member or some remote server in some other data center, you can't even remote desktop to it. It's okay, because you can still rest assured that once you get the box back up again, you'll be able to come up and kind of dig up the body here and do an autopsy on this thing, right? And that's done through a different part of perfmon than where most people go in this first tab, and that's under data collector sets. So what I'm going to show you is how to use perfmon, how to understand the interface in perfmon, how to build your own user-defined data collector sets, and oops, I need to kill that one, and how to delete a data collector set. There's one right there. There's lesson one. And how to actually then go get that data after the fact. Because basically the process is going to be, you're going to take the counters I'm going to give you, and you're going to load these into a collector, and then you're going to run it through a point of failure, and then you're going to stop the data collector set, and you're going to come in here and analyze the data. And it's not going to look like this with a nice little ticker going across the screen giving you a 1 second sample interval of whatever it is that we have loaded in the bottom, in this case disk and processor counters. You'll be able to fish out the counters you need to go and figure out what was the big bottleneck and then what process caused it. So that's what we're going to be beginning in this lesson, and that's what this performance series is going to be all about. So before we get into actually building a data collector set, we need to cover really quick a couple of things about the way counters look. And what we're going to do is we're going to use the live screen again. We're going to hit this plus sign because this brings a counter add tool up for you. And this is a good place for me to kind of show you what the different counters look like, the objects and the instances. Those are the three pieces that we need to understand. And in front of all of those is the path. For the purposes of troubleshooting, you should always gather information locally, even though from what this suggests, you can tell that it looks like you could actually add counters from other computers, and you can, which is great for trending analysis, and it's great for benchmarking, but for troubleshooting problems, you need to gather local. You need to save local, because if you have a bottleneck that causes you to lose the TCP stacks, for instance, you're not going to have counters from the point in time in which you are most interested in seeing. So, always gather with the local computer. If you ever do want to do some trending analysis and stuff, you can just do server. Whack whack server name. UNC path name out to the server that you are, yes, unable to connect to fake named machine. Not surprising. Anyway, whack whack server name, hit enter, and it'll go do a call out to that server and bring you back counters that are available for that system. But we are doing this here locally. So that's the path. Then comes the object. In this case, the object is processor, and you'll notice that there are lots of different kinds of process objects that you can come through and or not process objects, just objects in general. In fact, as we go forward and later versions of Windows and more software installed, you'll see more and more objects installed in here. There's only a few that we're super duper interested in. For instance, as I told you before, processors kind of important. That was the first one we saw. But things like logical disk, physical disk, these are all in here. Underneath, when you pick the object, each object will have a different instance. So the instance of an object is listed down here. Not surprisingly, when we go to logical disk, we see hard drive letters. And if I were to go to physical disk, I will see, if I can get my alphabet right, you'll see that the instances here are a little different. We get disk numbers with drive letters outside of them. And if we go to processors, we go to the processor object. Why can I not do alphabet today? You'll notice that there are two different processors listed. And that shouldn't surprise you. We saw that this is a two-core system before. In each one of these instances, there is also all instances, which is just star, and total. Underscore total can be very useful for some things. When it comes to processor, underscore total is an average. Even though that does seem a bit counterintuitive, it's just the way of the world. Underscore total is an average for percentage counters in most cases. If I look at process objects, this is a bit more of a thick set of instances because it's actually listing all of the processes that are on the box right now. Underscore total is a total of all of the processes for whichever counter you pick. And all instances means total and everything you see below it. This is one of those times where nothing is an average because these aren't percentage-based counters, at least most of them aren't. The other piece of this is the actual counters. So after you select an object, when you click the down arrow, that's where you see all of these counters. So some of these are obvious and some of them aren't very obvious. Like if you don't know what a handle is, which you probably do, but let's just say that you weren't too terribly sure what a handle is, and you wanted to know what a handle count might be, you can actually click Show Description. As long as you're looking in the live view, you can come down here and there's a nice little description of what that is. So if you are not too terribly sure what ID process is, well, ID process is the PID of an object. Well, we're looking at process counters. Every process has a process ID. PID in Task Manager or Resource Monitor, well, that is an actual counter that shows up inside of Task Manager. And this is important to understand because you might not think of something measurable to come from a process ID, but if I look in Task Manager and I go in here to the details on processes and I see like a PID for stuff like this desktop Windows Manager right here, it's at 3412. So if I were to add in the DWM process and look at it, Looks like there's two of them, so we might want to add both just to make sure we know for sure it's there, and click it. When we go down to ID process for DWM, and it's number 1, I guess, you'll see that the actual value is 3412. That's very, very confusing for people who see this the first time because they're used to process performance monitor rather, measuring things like average disk times and percent of processor utilization and available megabytes. Why would we measure a PID? Well, so that you can have it, right? This is a way for you to go and get that data out of a process. So the path comes out here on the side. So let's say that we were looking at just something very, very obvious like percent of processor time for processor core 0. If I add that in, you'll see that it shows that the counter is processor time and the instance of that is 0, whereas if I had added in all instances, it comes up as a star. So percent processor time, everything. And the same thing happens when I do that on process. So if I say I want all counters and all instances and add that in this way, I get process star star. What that means is the object process, that's once again this window here, which I'm not sure if the mouse is actually showing up, but I'm moving things around to change the highlight. So in this box, once again, object, that's right here, object process, will have all of the object process counters, that's these little guys highlighted in blue right here, that's the counter is star, and instance means all of these guys down here, all instances star. Right? So you can get as specific as you want with these, but understanding the actual counter path is kind of an important piece here. So basically you could say whack whack path, which in this case was local, right? Local host, but it could also be a remote server. So then after the path will become the object, and then after the object will come the counter, and then the instance. But that's not actually how it's listed when you go and look at these things. When you go and start pulling these and need to see an actual object path as it would be listed in perfmon itself, it's going to look a little bit different. So we'll cover that real quick. And the way that actually looks is, once again, path, which again could be a remote server, it could be the local computer, and then the object, and then the object's instance, so possibly just underscore total, or maybe star, and then the actual counter itself. So that would be, from what we saw from before, would be local host, and then processor, and then star for all processor type counters. Or if we were doing processor, it might be percent of processor time. I think there's actually a space in there. Or 2, because the instance for the processor in that particular case was instance number 2. So this is how we would define these. This will become important a little bit later when we talk about managing perfmon from the command line. But just for now, just to kind of talk about how we actually do it, we do not do it like that, because that is incorrect. This is what we talk about when we talk about a counter path. You won't use them very often, but it is helpful to make sure that we have them distinct in our minds as to what the difference is as far as these go. You have to be kind of picky too sometimes. When we start using star dot star on things, especially ones like this one, like the process star star, when I click OK, this thing's going to not even be able to add everything into the window, but it's going to do its best. See, now we've got just a screen ton of stuff going on in here. See what's going on? I've got every single counter that this box knows how to read for every single process that happens to be running. So that's a bit of a problem, and it's too big of a mess for us to sit on. It also makes the graph impossible to look at. So we want to be a little more selective. Even if we're not selective building our data collector set, we will be more selective actually using the data collector set to analyze data later after we have our capture, right? So how do we do that? How do we create a data collector set? By the way, I'm going to do a Control A and we're going to hit delete. And now we're clean again. We have nothing going on. Okay, so a data collector set, this is something that you will do to go and grab the data so that it will start running this sucker, and then we'll come back later and look at that data. So we just right click and we say new and we say data collector set, and we'll give it a name. And then we'll say create manually this time. There are templates out there, and I'll show you where you can get some really cool ones. But we're going to do one manually just so that we understand the process. And then we're going to tell it that it's a perf counter. We're not doing any event trace data or system information at the moment. And then we're going to go ahead and add in some counters. So important counters we'll talk about later. Just for now, so that we have some stuff to get in here, we'll go ahead and add all of the process counters. Let's be selective so this thing doesn't get massive, with maybe percent of processor time for all instances, and maybe let's see, handle count ID process. Let's do IO read operations. Oh, I forgot to control. So I hold down my control key. When I'm adding these, I can do percent processor time and then click down, read operations and write operations as second. And let's go see if there's any extra stuff that I want to put in here. Private bytes is a hugely important one. Virtual bytes entirely important. And then the working set, hugely important. So now we've got the disk usage, the memory usage, and the processor usage for every one of the processes running on the box. So rather than it being a star, I've picked out like 6 counters that I think are important to me for every process on the box. Okay, and the neat thing about using the star on the instance, this is important because rather than picking specific processes, I have picked every process with my favorite counters that I like to look at for process analysis. Now, why is that important? Because I didn't pick just like click here, shift to the bottom, shift click, and then add. If I had done that, I would only get these processes. What if another process kicks up on this particular system 5 minutes after I start the capture? Guess what? It doesn't capture it. Right? So it's important to have the star when we're talking about things like the process. But we continue on. We'll just grab some other stuff. We're not going to go through like every one of the counters we're going to cover in this series, but let's get some important stuff. Obviously, processor time, kind of important. I like to go ahead and get all instances. You might be thinking, oh, well, I can just do underscore total. I'll get a percentage of all of the processor utilization across all the cores on this system and save some counters. Don't do that. Why? With processor, think about this. One of the things that might be causing your system to be slow might be the application. People experience things through the interface they're using. So if all they're doing is using a back-end application that a server is running, they're going to think that server is slow, even though it may not actually be. It could be that they think that server is slow because the application they use off that server is slow. What if it's a single-threaded application that is sitting at 100% processor utilization? You have 32 cores on the box. The box looks just lovely, but the process is sitting at 100%. If you look at average, you're going to see what, 3-5% processor utilization, even though the reality is that thing is actually running at as high as it possibly can, making the application seem slow, but not something you can ever see in Perfmon because you gathered the average of 32 processors when only one was busy, right? So for those of you gamers out there, like Minecraft, right? If you're running a Minecraft server and your Minecraft server, which only can run on one core unless you've modded it, will show on an average that there's not a problem on the box, whereas Minecraft might be absolutely beating the heck out of one of your cores. So anyway, digressing a bit here. So let's get some other interesting things like DPC, not DPC's queues, just interrupts a second and the percent of DPC time instead. And let's get, where's the kernel time? Percent of user time, there it is, privilege time. Okay, that's kernel time, by the way. All right, so we've got some processor stuff, we've got some individual process analysis type stuff. We need to get some disk counters, so we could do physical or we could do logical. We'll talk about the difference between that later. I just want to have some stuff in here to work with, so we have a working counter set. So maybe percent free disk space, percent of, or average disk per second read, average disk per second write, average disk queue length. Where did it go? Average, it must have been an average disk queue length for C drive. What else do I want on this? Disk bytes per second, and free megabytes. We've already kind of got percent free disk space. Percent of disk time, not a bad one to have, not one we're going to go into a lot of detail with. Okay, so I promised you weren't going to get super detailed. I get a little bit anal about these. Memory, obviously incredibly important. We'll skip network for now because I'm taking too much time just throwing random counters in here. Percent of committed bytes in use. You'll notice with memory there are no instances. That's to be expected. There are no instances because there's just one memory, one set of RAM, right? So percent of committed bytes in use, available megabytes, and let's see, we don't need commit limit or committed bytes because we've got percentage counter that gives us that. Free system PTEs, and I know everybody thinks pages per second is cool. We're not actually going to use that, and I'll explain why later, because it's not nearly as important as everybody thinks it is. System cache resident bytes is pretty important these days. And why am I feeling like I'm not getting everything I want? Yeah. How much RAM in page file? We've got those. Bang, bang. Okay, let's just go with that. So that's a discussion. Those are our counters. Now here are the counter paths. You don't see the actual name of the box, and the reason for that is because we're doing localhost, so it's not going to display here. So we've got the counter path. You'll see it's logical disk, and then the instance of C, and then percent disk time. Down here, memory, no instance name because there's no such thing. Process, everything, percent processor time. See how these work? Not that hard to figure out. It's just getting the lingo right, getting the interface. Sample interval. How often are we going to take a picture of this? You might be tempted to set this to 1 second, but you got to remember that everything that you set here may have an impact. Setting something to 1 second with a whole bunch of counters could actually create more of a performance impact. Not much, but it does actually impact the system. So 5 seconds, is that the answer? Well, it just really depends. But this is a very important question to be asking yourself, and that's based off the problem. So if the problem happens every 2 hours and lasts for 45 seconds, then you don't want to take a 1 minute sample interval because you won't catch it. But if it only lasts 15 seconds, you might want to grab a 2 second or a 5 second sample interval so you get a little bit of a picture of what bad looks like surrounded by a picture of what good looks like, because you don't want your sample interval to skip over, but you also don't want your sample interval to be so small that it creates a lot of disk activity, fills up your drive with this this capture, and potentially creates a bigger problem than it's worth. So just be kind of cautious about this. If you're just going to have an always running black box counter, which I'll show you how to do in another episode, if you're just going to have this sucker running all the time, then what you need to do is probably around a 10 or a 15 second sample interval. That's pretty good balance right there. So we click next, asks where do we want to stick this thing. We'll just leave the default for now. That's just where the BLG file is going to go. If you need to run it as a different user, modify that here. Otherwise you click finish, and voila, you have your first data collector set up and running. The next part of this series, we're going to be talking about what to do with these fancy little data collector sets, but before we do that, we got to get this guy going. So we'll go ahead and right click, and before I do that, see, I always forget this, and I preach this and I never practice it, and I'm horrible about it. First off, before you start a data collector set, save yourself the headache of screwing up later. You need to have under file, first we start with the actual properties of the collector set, and we want to have the stop condition set for something. In my case, I always like to go in here and like put 2 gigs. just as a, I don't want you any bigger than 2 gigs, or whatever your needs happen to be. If you need this running longer and you have lots of disk space, then go for it. If you do that and then come in here and go to properties on the data collector set, you'll notice that this circular logging, which a moment ago was grayed out, but now is not. You have to have a stop condition in here to turn on circular. All this means is when you get to the end of 2 gigs, just start throwing out the oldest stuff and just keep running. Right? Just like your event logs, right? You have an option to do that as well. But this keeps you from accidentally forgetting you were doing this. You're like, hey, I'm going to play with these data collector sets, set it, get it running, and then 2 months later somebody's calling you because your server that you were playing with is out of disk space. Not good, right? Now we can go ahead and start it. We're going to go ahead and have a little counter set that we can play with later that'll be already running on this this box. And that's how you create a data collector set. Now, the most important thing about all of this that we skipped over, and that's kind of the point of this class, is going to be the data collectors themselves and what they mean. Why are they important? What do they mean? Why do we care about them? What are their thresholds? Right? What would we consider a problem? What would we consider an emergency? What do we consider what good looks like? And that's the whole point I'm going to cover with you guys, and that's probably the most complicated thing about perfmon and general performance troubleshooting. So that's where we're at right now. So we've got ourselves a data collector set. In the next piece of this, we'll talk about what do we do next. But anyway, guys, this has been Chris with Microsoft, and as always, I thank you so much for watching. If you did find anything about this first episode here useful or interesting, please feel free to give it a quick like, and if you subscribe to my channel, you'll know when I post the next episodes of these, assuming you're not watching this far down in the future and they're already all posted. Still going ahead and giving me that subscribe, you'll get a little note that says anytime I release anything, because I do like to do these videos. Anyway, my blog is at 9z.com. It's real super easy to remember. It's just the last number followed by the last letter .com. That's also got links to my Facebook, my LinkedIn, my Twitter, and my TechNet blog. So again, thanks a ton for listening, and I will see you guys in part 2 of this series.